All right, so let's take a look at a couple problems on page 24, graphing quadratics that are in standard form. So if I look at this quadratic, to get it in factored form, I need to decide if it's type 1 or type 2 of factoring. So since there's no constant here, this is just type 1 where, and I'm going to set this equal to 0, I'm going to factor out a GCF. So the GCF of these two terms is 5x, which when I factor that out leaves me with x minus 2. The reason I'm setting this equal to 0 is so that I can also find the x-intercepts, because the x-intercepts are the values of x that make an equation equal 0. So 5x equals 0 is one equation, and x minus 2 equals 0 is the other. If I divide both sides by 5, I get x equals 0. And if I add 2 to both sides, I get x equals 2. So factored form is what I got when I factored out the GCF, 5x times x minus 2. And the x-intercepts that I got from that are x equals 0 and x equals 2. When a quadratic is in standard form, the y-intercept is always c. So technically c here is 0, so the y-intercept is also 0. The axis of symmetry occurs at x equals, and we use the opposite of b over 2a formula. So opposite of b, in this case, is positive 10 over 2a is going to give us 1. So the axis of symmetry is 1, which means the x-coordinate of the vertex is also 1. And then I'm going to plug 1 in for x to this equation, which when I do that gives me negative 5. So my vertex is at 1, negative 5. So let's plot all this information. I have an x-intercept at 0 and at positive 2. The y-intercept is at 0. The y-intercept and the x-intercept in this case are the same. And then 1 and negative 5 is my vertex. So this is my parabola. So let's try this one. So we need to start off by getting it in factored form. So since this is going to be type 2 factoring, because I have two variables and an a value, and a c value, a constant value, I'm going to need to do AC method. So that means I'm going to need to start off with my cross by multiplying a, which is 1, times c, which is 25. 1 times 25 is 25. So I'm looking for what multiplies to be 25, and it has to add to be 10. So the two numbers that would work there would be 5 and 5. So I'm going to take my quadratic, and again, setting it equal to 0, write it as x squared, and then I'm going to use these two magic numbers that I just found, plus 5x, rewrite the middle term, 10x, as these two numbers, and then plus 25. So I'm just taking my quadratic and rewriting the middle term using my two numbers I found using my cross. So now we're going to group the two portions of the equation together and find each's GCF. So the GCF of this first group is x, and the GCF of the second group is 5. So one of my binomials, or one of my factors, is going to be x plus 5, just combining those two GCFs together. And then my second binomial is what I get when I divide by that GCF. X squared divided by x is x. 5x divided by x is 5. And if I check my second group, 5x divided by 5 is x, and 25 divided by 5 is 5. So that tells me that I did it correctly. So this is my factored form, x plus 5 times x plus 5. And then from there, to get my x-intercepts, I'm going to set both equations equal to 0, which technically they're really just the same equation. So I only have one solution in this case, and that's x equals negative 5. The y-intercept is my c value, which is 25. My axis of symmetry is at opposite of b over 2a. So it's at negative 5. And if I plug that value in for x and I do negative 5 squared plus 10 times -5 plus 25, I actually get 0. That's because in this problem, the x-intercept and the vertex are actually the same point, which kind of makes sense because we know that one solution only touches the x-axis once. So I really kind of want just 2 more points here so that I can make my graph, because 25, the y-intercept, is so far off the graph that it's not really helpful right now. So I'm going to go all the way back to unit 3, and I'm just going to make a real quick table for this. I'm going to go 1, 2 x values above and 1, 2 x values below, just so I can have some other points to plot here. And then I'm going to plug in -7, which if I do that, I get out 4. If I plug in -6, I get out 1. If I plug in -4, I get out 1. And if I plug in -3, I get out 4. So I just took all of these x values and plugged them into my equation for x, just again, so I would have some other points to plot. You really don't need to do this in most cases, because in most cases you'll have 2 x-intercepts like we did on the last one and a vertex, and that'll give you plenty of points to graph your parabola. But in this case, because I only had 1 point from all of this information I could plot, I did decide to make a table to get just a little bit more information to graph.